the Hilbert Hotel. Let's take a moment to really explain what countable infinity even is, because that is probably the reason that makes this paradox so confusing and hard to understand. What is Hilbert's Hotel? So imagine a hotel that has an infinite number of rooms, numbered 1, 2, 3, 4, and so on, all the way to infinity. There is no end, and now you might think if every room is full, there's no more space then. But here's where things get a little strange. What does countable infinity mean? This is a type of infinity where you can list all the elements one by one like a number line. Countable infinity doesn't mean huge infinity. It just means you can keep counting forever without running out of numbers, and think about counting from 1, 2, 3, 4, and so on. You can keep counting forever. That's what makes this infinity countable. Okay, so back at the Hilbert Hotel, someone new arrives, and you are the hotel manager, and you're trying to figure out how the heck you're going to fit this person in. In a normal hotel that is full, there's obviously no space. But in this infinite hotel, we can still make room for the new guest. How? By asking each guest to move from room 1 to room 2, from room 2 to room 3, from room 3 to room 4, and so on. In other words, rooms n move to rooms n plus 1. Because by shifting everyone over, room 1 becomes available for the new guest, even though the hotel was full. This works because in countable infinity, there's always another room you can move someone into, no matter how many rooms are full. There's always more space. The same thing can occur with any new number of guests less than infinity, because I will get into that case in a minute. But if you had, for example, 1,000 people coming to the Hilbert Hotel despite it being full, okay, the reason you would deal with that is not n plus 1, it would be n plus the number of people coming in. So if you had 1,000 people coming into the Hilbert Hotel, you would do n plus 1,000, not n plus 1. If you had 2 people coming, n plus 2, 3 people coming, n plus 3, and so on and so forth, you would put that many number of people in addition to n, and you'd have people move that many spots. That would keep the first set of rooms of that number empty for the new guests. Infinite number of guests coming in. How would you deal with that? Okay, you might think that there's no room left because infinity is full, it keeps going, but they're all full already, so there's no way you're filling in n plus infinity. That's not happening. Well, here's where it gets even more mind-blowing. The manager doesn't just shuffle people around by one room or a few rooms. Instead, here's what's going to happen. Room n would move to room 2n. So the new guests take all the odd-numbered rooms. So again, an infinite number of new guests can check in this case. And here's the thing. Even though the hotel had an infinite number of rooms already filled, you still managed to fit in an infinite number of guests. Countable infinity allows for this. And it comes down to the idea of infinite sets. The number of rooms in the hotel, all the numbers 1, 2, 3, 4, 5, and so on, is what we call a countable infinity set. But did you know that there is also a set of even numbers, 2, 4, 6, 8, and so on and so forth, that is also countably infinite? And here's another thing. These two sets, the set of all natural numbers and the set of even numbers, are the same size. They're both infinite, but there's no end to either. Same thing with an odd number of sets. A set of odd numbers that are also infinite. They are just the same length as a set of countably infinite even numbers. So it's almost like there's multiple infinities at play here. So why is infinity different? Again, even though it seems like even numbers are half of the natural numbers, they still go on forever, just like the natural numbers do. But this is what shows that infinity isn't just a big number. It's a concept that can have different sizes, forms. And countable infinity means that there's always a way to list the elements, even if they go on forever. And it's not about how big infinity is, but about how we can work with it.